Hello guys, today we are going to see how to read, explain or interpret the two-factorial experiment, agricultural experiment, SPSS result. So first of all, we are going to analyze our data. As I showed you in the previous videos, we can analyze it in such a way that we can choose this multivariate because we are going to analyze more than two dependent variables. So we can go ahead and choose some of the dependent variables. For example, we can choose these three dependent variables and these two factors, fixed factors or independent variables. Then after that we can go to the post hoc and choose both factors and highlight on LCD and Duncan, continue, and go to option, descriptive statistics and homogeneity test, continue, then click on OK. We already analyzed our data. Then we just go to our result SPSS output page where we can find the analyzed result. Then this is the one of the dependent variables which we are interested in. This is pod length. So we can take the data in such a way that first we can just right click, copy as Excel worksheet, then we can take it to Excel sheet, right click, then paste it. We can have it here now like this, so that we can simply copy and paste on our Word document. Here, as you can see, we can copy these numbers or one by one. We can copy it and take it to our Word document. As you can see, the first one is 11.84. You can see it here, 11.84. The second one is 13. The second one is 13.25. So in such a manner, I can copy it and paste it here in my Word document. Then after finishing copy and paste all the data I have, we can write this significant signs and this labeling these letters A, B, B, C. How are we going to write them? We can see this also. From here we can go to the test between subjects effects table. We can go to this table and see if it is significant. Our interest is this one, the pod length. So is it significant under the effect of salinity? This is salt, our one of our factors, fixed factors. So this one is significant because the value here, the p-value is less than 0.05. So we consider this as significantly affected by salt. This dependent variable is significantly affected by this factor, which is salt. And if we can see the second factor, which is silicium, we can see this pod length, which is not affected significantly by silicium. The second factor didn't affect our dependent variable significantly, because we can see this is not less than 0.05, so it's not significantly affected. And we can see also the interaction effect. When we see the interaction effects, this is our dependent variable. When we see its p-value is not less than 0.05, which is not significantly affected by the interaction effect of the two factors. So here we can see that we wrote it as significantly affected by the first factor, which is salt, then which is salinity level of the average salinity levels are this in different levels of silica, so this is significantly affected. And when we see the silicon level in different levels of salt, the average, the mean silicon level, we put non-significant here, NS, which is non-significant, because the pod length is not affected by silicium, different silicium levels, but affected by just salinity. So where do we take these levels? How do we know this? It's it's A, this one is AB, this one is C. We can see it from the homogeneous subsets table from here, the same SPSS result. We can just go ahead and see these tables, these small tables. So this is our dependent variable, which we are interested in now. Here we can write A so we can go to the homogeneous subsets table. So this is our dependent variable. This one is A, so the highest number, the biggest number will be labeled as A. Then the second one B, but since it's in the same column, we can say it's A B, which is here, which is why we labeled it A B 7.67. This one is A B, and this one is B, this one is C. That's how we label them. Then we are going to interpret it. We can say that the variance analysis result of pod length data, which is one of the the yield parameters, did not show any significantly difference at the level of this factors interaction. The interaction effect didn't show any significance. That's what we can say, as one of the explanations. We can also further explain that it was determined that this is significantly at 1% level of significance affected by the salt factor. And we can also explain that the decrease by the salt level is by this percent. We can calculate it from the control value, from control, which is 0 salt level. We can compare it with the control and calculate the decrease from the effect of salt level. So we can interpret it in such a manner. This is one of the examples. You can take it as an example to analyze your data. This is for